In this section 3.8, we're going to look at a different equation of a line. Up until now, our equation of a line is written as the starting point plus the slope times a variable. All right, so this is called slope-intercept form. Why would this be called slope-intercept form? Because you have the slope. In this case, it would be up 3 over 8, up 3 over 8, up 3 over 8. And you have the y-intercept. When x is 0, where does it cross that vertical y-axis? All right, so there are other forms for the equation of a line, and we're going to learn a different one today, point-slope form. So here's our application. Tires have tread on them to channel away water to improve grip on a dry surface. The height of the tread on a tire is referred to as tread thickness. And so here we have a table of tread thickness for a particular set of truck tires based on the number of miles the truck has been driven. So this is in thousands of miles. When the truck has gone 15,000 miles, the tread thickness is 7.2, and that would be millimeters. When the truck has been driven 35,000 miles, the tread thickness would be 4.8 millimeters. So we can change this table into these two ordered pairs. And as you would assume, the more miles you put on a set of tires, the smaller the thickness will be. The thickness wears away. Your tires wear away until eventually it can become what's called bald, which means you have no tread on your tires. And that's why tires don't last forever. So, do you think it's reasonable to predict that the relationship between tread and thickness is linear? In other words, the more miles, the fewer miles, the thicker the tread, the more miles, the smaller the tread. I don't know, this is an opinion question, but I think it's probably linear. So let's continue with question 2. Find the rate. Whenever you see find the rate, that means find the slope. Rate of change is slope. Whenever you hear rate of change, that's math keyword for slope of the line. So find the rate at which the thickness is changing compared to thousands of miles, miles driven. So if we have these 2 points, my slope is the difference in the y values over the difference in the x values. And here are my 2 points here. So that's going to be 7.2 minus 4.8 in my numerator, and 15 minus 35. And that's going to come out to negative 2.4 over 20. Actually, the negative is in the denominator. And that would be negative 0.12 millimeters per thousands of miles driven. So my slope is negative 0.12. This is the slope of the line. Now question 3 asks, why was it smart to write miles in thousands rather than the actual mile numbers? All right, well, let's assume we didn't say this was 15,000 and 35,000. Let's see what we're going to get. That's going to be 15,000 minus 35,000. And when you do that calculation, what you get is negative tens, hundreds, thousands, 10,000, hundred thousandths, 1,200 thousandths of a millimeter. And that number is pretty hard to make sense of. It's hard to imagine that small of a change per mile. It's easier to think of, this is even still a small number, but this is easier to grasp per thousands of miles. All right, so question number 4. This is where we're going to introduce the new type of equation of a line, and this is called point slope form. We already know slope-intercept form, but point slope form is y minus a y value is going to equal the slope times x minus an x value. So here's the x value of a point and the y value of a point, and here's our slope. So there are 3, if you will, slots to fill in. If you have a point, you have an x value and a y value for the point, and you have a slope. And we have that here. Let's go ahead and let's pick the point 15, 7.2. Point slope form would be y minus 7.2 equals, and remember my slope is negative 0.12. Open paren x minus 15. That's it. There's my y value, there's my x value, and there's my slope. So question number 5 says, write the slope-intercept form of the equation that describes the relationship. All right, so we have point slope form. I'll just rewrite it from the previous page. We have this equation, and we want, this is asking for slope-intercept form. Y equals our starting point plus our slope times x. We'll leave the y minus 7.2 for right now. Let me distribute the 0.12. So negative 0.12 times x is negative 0.12 times x. And then negative 0.12 times negative 15. Negative times a negative is positive 1.8. And for slope-intercept form, we want the y by itself. So we're going to add 7.2 to both sides. So here's my slope, negative 0.12, x, that's my variable, and 7.2 plus 1.8 is 9. Y equals 9 minus 0.12 x. And by the way, we would have gotten this equation if we had done y minus 4.8 equals negative 0.12 x minus 35. I'll leave that for you as an example, but you could either pick this point, the 15, 7.2, or you could pick this point, the 35, 4.8, and you would still come up with the same equation. So this has the slope first, and this has the starting point first, or the y-intercept first, but they are equivalent. So here we're asked now to graph the equation and the 2 points from the table. If they don't live on a line, if they don't line up, that would be bad, right? Okay, so let's see. We're going to put tread thickness in millimeters. here. And let's put miles driven. You know what? I'm going to change that around. The answer key has it this way, but my points were 15, 7.2, and 35, 4.8. Pardon me, this would tell me that the first value is the miles driven, and the second value is the tread thickness. First value, miles driven in thousands. This makes more sense. And over here we're going to have tread thickness. And that's going to be in millimeters. And that actually makes more sense because the input would be how many miles have you driven, and the output would be the tread thickness. In other words, what's the tread thickness on your truck? Well, that will depend on how many miles you've driven the truck. Independent variable, dependent variable. Okay, so miles driven here has to go between 15 and 35. So let's see if we have 5, 10, 15, 20, 25, 30, 35. That's pretty good. 5,000, 10,000, 15,000, 20,000, 25,000, 30,000, 35,000, 40,000 miles along our x-axis. And along our vertical axis here, tread thickness, our smallest value so far is 4.8 and our largest value is 7.2. Okay, so let's see what we'd have here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it looks like going up by ones every grid will be fine. So if that's 0, that would be 2, 3, 4, 5, 6, 7, and 8. So let's put these 2 points on there. 15, 7.2. 2, 4, 6, 7. There's 15, 7.2. And 35, 4.8. 35, 2, 4, 4.8. And that would be our line. Question number 7 says, to use your equation to predict the thickness when the tires have been used for 50,000 miles. Negative 0.12 x plus 9. So for 50,000 miles, that's when x is equal to 50. And that's going to be, once you do your calculations, negative 6 plus 9. So we would say 3 millimeters. Here's 40, 45, 50. Yep, that's very close to 3 right there. So the graph seems to be accurate, and our equation seems to be accurate. So question number 8 says, according to the U.S. Department of Transportation, a minimum safe tread is 1/16 of an inch. Convert this thickness to millimeters. So we want to convert 1/16 of an inch into millimeters, which means we're going to have to multiply by a fraction with millimeters in the numerator and inches in the denominator. Once we have 1/16 of an inch in millimeters, then decide how many more miles the owner can drive till he gets there. And we're told right here 1 inch is 25.4 millimeters. So inches cancel, and we get 25.4 divided by 16 millimeters, and that's approximately 1.59 millimeters. So that's the smallest tread that you can have to be on the road safely. All right, so how many miles would that be? When my tread thickness is 1.9, negative 0.12, I want to find x. I want to find the number of miles to have this tread thickness. So subtract 9 from both sides. 1.59 minus 9 is negative 7.41. That's going to equal negative 0.12. X, divide both sides by negative 0.12. And that's going to be at 61,750 miles. 61.75 thousand miles. All right, well, right now, if our table ended where the miles on our truck were 35, so right now I have 35,000 miles, and I can drive up to 61.75 thousand miles. So 61.75 minus 31 is 30,000.75 miles. Or we'd probably write it like this. You can drive on that truck another 30,750 miles before it's not safe. Oh, you know what? I think I did. Did I type in the wrong number? Yes, 61.75 minus 35. Huh, look at that, even having a calculator. It's not going to give you the right answer if you type in the wrong number. I typed in 31. That is 26,750 miles. And finally, that particular model of tire has tread thickness of 9.2 millimeters when brand new. Does this match what your model predicts? Well, let's go ahead and look here. Let's just look on our graph. Brand new would be 0 miles. Look, it's just over 9. So I would say, yes, this is a good prediction.